Hello, we're Team Spot, a multidisciplinary senior design team in the Kate Gleason College of Engineering. We are working with a local food manufacturer to analyze production data in order to identify and implement process improvements. Our key goals are to create a database to help identify future improvement opportunities, implement improvements to the changeover processes, and enhance real-time sensing.
Our database utilizes Excel macros to automatically analyze updated data from the customer's maintenance and production software packages. This analysis is neatly displayed onto two dashboards. The first dashboard highlights key information on maintenance work orders and helps to identify assets that frequently require corrective maintenance. This data can be used to focus improvement efforts on those pieces of equipment that frequently have issues. The second dashboard focuses on production changeovers as they are the main source of downtime.
While observing the existing changeover process on the company's main lines, we noticed operators struggling to calibrate the packer machine. The main issues revolved around having to manually line up the rails of the machine with a series of ruler marks, and then having to later redo these adjustments when they are inevitably determined to be incorrect. The jig simplifies and standardizes the adjustment of these rails so it is done accurately the first time, while also being done faster in the first place. Together with the Standard Operating Procedure, SOP, we estimate that the time needed to change over the case packer machine will be reduced by 70%.
Of the many types of sensors on the two production lines we were involved with, clear object photosensors were the most abundant. Through interviews with personnel, it was discovered that gain sensitivity adjustment of these sensors was ad hoc. A sensor was borrowed from the client for empirical testing offline. Through this testing, a best practice procedure to adjust this sensitivity was developed, which improves the signal output accuracy from the device by as much as 50%. It has been recommended to the client to implement this procedure to all clear object photosensors in the future.
One of the most difficult decisions we had to make with this project was where to begin. Our project description was open-ended from the start. The first half of MSD1 was spent working with our client to determine our best course of action. For example, we were ready to begin work in one area of the production line, but due to confidentiality issues, we had to quickly pivot to a new focus area. We'd like to thank our client and sponsor for meeting with us, the ME Machine Shop staff for helping us manufacture our system, the technicians and operators that helped us understand the different processes, and Company X for their donation of components. We'd also like to thank our guide, Don Pofel, for his steadfast guidance and advice.